let's go ahead and look at these. I know some of you are still finishing up that graph. That's okay. All right, so the first one, when you go to try to solve that, you go, oh, well, it doesn't factor, so now what do I do? Okay? Do you know what that's a graph of? Which shape is that graph? Like, it's a parabola, right? You know that's a parabola. You don't have to go into the detail of, like, finding the vertex and all of that to graph it. Do we know which direction this graph is going? Like, is it facing up or is it facing down? Facing up, right? And do you guys see how every term is positive? So it's somewhere up here, right? I don't know exactly where the vertex is. I can find it opposite of b over 2a, all that stuff. But if everything is positive, it's above the x-axis, right? So I'm asking you, when is it greater than 0? When is it above the x-axis? What do you think? Yeah, it's always above that x-axis, so negative infinity to infinity. What if I'd asked you, when is it less than 0? You got no solution, right? It's never below 0. Okay. So if you get a problem like that, that you're like, oh, it doesn't factor, but it's something fairly simple as far as the graph, just think through it. I know I keep saying, oh, you just think about it, guys. But that really is a lot of what you have to be able to do, is just make that connection to, okay, I know what that graph looks like. Can I answer the question? Okay. All right, the second one here is much more the traditional number line. Let's figure it out. So it looks like we have -5, -3, 1, and 4. I'm testing 0 because it's easy. 0 plus 3 squared would be positive. 0 minus 1 cubed, that'd be negative. 0 plus 5, positive. 0 minus 4 is negative, but then I square it, so it's positive. So I see one negative out of all of that stuff, so I know that little region is negative. Are we okay to that point? Okay. I do not feel like plugging numbers into that. Okay, so I'm just going to use what I know about multiplicity. I see a couple of even multiplicities. Okay, I see it on the -3, and I see it on the 4. The odd multiplicities, I don't care about. Even, that's where it's going to bounce. It's going to do the same thing on either side of it. So for the -3, since it was negative on one side, it'll be negative on the other. But then it'll alternate after the next 0. Going to the right side there, the 1, that did not have even multiplicity, so it's going to alternate. But the 4 does, so it's going to be positive on both sides. So let's take a minute, look at that number line. Are we okay? Getting it? We're getting how the multiplicity works? Just kind of work your way out from the one thing you know. Okay. Then I have to look at what the question's asking me. It is saying less than or equal to 0. So that's the negative stuff. Okay, so it's just those two little sections. Less than or equal to, so you go, oh, I'm including all of it. Am I including every point on that number line? Which ones am I not including? And? What's the other one I can't include? I know it doesn't matter for my answer, but what's the other one? 4, okay. But I am including the -3 and the 1. So your answer, you could write it just parentheses -5 to 1 with a bracket. How'd we do on that one? Did we get it? Yes? Yes? Okay. All right. Progress. That's good, guys. Okay, let's look at our graph now. Questions on that? Question?
If it's negative between the range from -5 and 1, how can you write it as -5 and 1?
So it's negative between here, and I'm looking for where it's less than or equal to 0. Were you thinking greater than? Okay. Yep. So always go back to what the question is asking.
Can you go over why it can be negative 5 and 4 again?
Yeah, so if I plug negative 5 in right here, what do I get?
0.
That's in the denominator. Okay, that's gonna just keep coming back. Okay, let's look at our graph. All right, for a log, what are the 2 points I'm gonna start with? 1, 0, yep. And 3, 1, good. It's always 1, 0, and then that base 1. Okay. With this equation, because I have that negative in there with the x, I'm going to rewrite it. Negative 2 log base 3, factor out a negative. That'll make that x plus 2 plus 1. We're okay there. All right. So the first thing I'm going to do is deal with the negative 2 in front. That's essentially a flip and vertical stretch all at once. It means just multiply y values by negative 2, okay? In that same step, I can deal with this negative in front of the x. What does the negative in front of the x do? Flip over the y-axis, okay? Essentially multiplying the x values by negative 1. Okay, so I'm going to rewrite these points. So the point 1, 0, that's going to become negative 1, and then still 0, because 0 times negative 2 is 0. 3, 1 will be negative 3, negative 2. All right, then what's the last thing I have to do? Okay, guys, where am I going? Left 2, yeah. Left 2 and up 1. The left 2, that's the tricky part. Initially, it looks like it would be right 2, but if you rewrite your equation the right way, it's actually left 2. So I'll count over 2, and up 1, over 2, up 1. And where's my vertical asymptote? Yeah, remember guys, it's always going to match that horizontal shift. So it'll be here at negative 2. So your graph looks kind of like that. Are we doing okay graphing? Yeah? No? Okay. Do you understand it now?
Yeah, I wrote down the problem wrong, so then I just messed up everything
Oh,
else
yeah.
in my life.
You kind of have no chance then.
Yeah. Yeah.
Anybody questions on the graph? Questions on anything? Some of your faces tell me that you have questions, but yeah, go ahead.
Should we always take out the negative if it's a negative x minus?
Yep, anytime, and when we get into graphing trig functions, you'll see it even more. But if it's any coefficient on that x, like if I had negative 2x plus 4 in there, you would actually need to think of that as that. Okay. You're not going to see numbers too frequently with this. You're really just going to see the negative. But further into the year, we will see coefficients. Okay. All right. Anything else? Okay, we're jumping into notes then. going to talk about properties of logs today. And really, it's just we're gonna go through a bunch of examples of the different things that you can do with logs. There's not a lot of like writing out the theorems or ideas like that. It's just let's try all these different scenarios and see how they go. All right, so the first one we're gonna do is expand. We have log base 5 of 25 AB. So the properties of logs are very much connected to your properties of exponents. Okay, remember logs and exponentials are inverses of each other, so the properties work very similarly. Think with exponents. If I'm multiplying, like if I have like a cubed times a squared times a to the fourth, what is that? Yeah, I was like, oh, a to the, let's count. What did I put? Yeah, a to the next. You add the exponents, right? So similar idea here when we're doing the logs. We're going in reverse here. We're trying to expand this into as many logs as we can. I see 25 times a times b. Multiplication, I can expand out with addition. So this is really log base 5 of 25 plus log base 5 of a plus log base 5 of b. When you expand, you'll have the log with the same base in each term that you're expanding it out into. Okay. Can I simplify any of those logs?
First one's just 5.
Close.
2.
2. You're thinking 5 times 5, right? Yeah, which is 2. So it is 2 plus log base 5 of A plus log base 5 of B, and that is your answer. All right, kind of the same idea with the same property here, but we're going to go the other way. We're going to condense. All right, so I will give you log base 2 of A plus log base 2 of B plus log base 3 of X plus log base 3 of Y. So when you're condensing, you want to write it in as few logs as possible. You're trying to bring as many of them together as you can. But you can only combine logs with the same base. Okay, so I clearly have 2 different bases. I'll start with the log base 2. What do you think it's going to be? Log base 2 of what? Yep. Plus log base 3 of XY, there you go. All right, so that's essentially your multiplication property for logs. Just go back and forth between expanding and condensing for a bit. So let's expand again. This time you have log base 3 of 27 over 2. Okay, so think back to exponent rules. What if I had a to the fifth over a squared? What would that be? A to the third. How'd you get that? Right, subtracted your exponents. When you have the same base, you can subtract exponents. Same idea here. We're dividing. So I'm going to expand this into log base 3 of 27 minus log base 3 of 2. Okay, because I'm dividing, I can expand that as subtraction. Are you guys seeing how they connect? Making sense? Okay. And then what is log base 3 of 27? 3. Good, there's your answer. 3 minus log base 3 of 2. We'll do a few more expanding here. All right, let's do natural log of 4 over 3e. And as always, guys, stop me if I go too fast or you need me to scroll back up through something. Just let me know. Okay, let me walk you through this one. It has division and it has multiplication, right? So let me show you how this one works. Natural log of 4 minus, I'm going to do it in a couple of steps. Natural log of 3e, right? Because that's the numerator minus the denominator. Okay, but that denominator I could expand. The way you have to write this, you're going to want to use parentheses. So it's natural log of 3 plus natural log of e. Do we see how that shows that the 3 and e are actually multiplied together, but they're the whole denominator? Okay. You could also write it natural log of 4 minus natural log of 3 minus natural log of e. Like you could certainly distribute the negative. And then, guys, what is the natural log of e? 1. 1, good. So natural log of 4 minus natural log of 3 minus 1. That's your actual answer. Questions on that one? All right, you guys try this. Expand again. Let's do natural log of 2x over 5y. And guys, you do not have to show like all of these steps like I did in the previous one. I just wanted to make sure you saw where everything came from. You can, if you see it, you can just go right to the answer. I'm fine with that. Chat with your neighbor once you've got it. Check and see if you guys agree. If you don't have a neighbor, check with someone in front or behind you. Okay. No neighbor. You what?
Where is he?
I don't know. like quietly checking with each other. We're very quiet this morning. Has it been a long week, guys?
Yes.
It's October tomorrow.
I'm so excited.
Kind of crazy.
I love fall.
So do I. I love fall. I love Halloween. All of it. So.
I just really like the cold, so I'm like, I love late fall. So my favorite thing.
I love when you get up in the morning and it's like crisp, you know, and you're just.
I think it helps to stay that way all day. Because like now it's like super hot outside, but it's really nice in the morning.
Yes. Yep. I'm with you. All right, guys, do we have answers? Okay, what is it if I expand?
2 plus ln x minus ln 5 plus ln y.
Do you have parentheses?
Oh, I'm sorry. Minus.
Yes, good.
I accidentally wrote it. I had parentheses, but I wrote it down as minus in the parentheses.
Oh, okay. Thank you. All right, guys, so that is your answer to the expansion there. Do we get it? Question? Yeah. Yes. Questions? Okay, we'll keep going. There's just a lot of little properties we've got to get through. All right, this time let's do log base 2 of 4 to the 6th. We're going to expand this, and then we're going to actually simplify it after we expand it. So regular exponent rules, power to a power, what did we do? Like if I had a cubed to the 4th, what is that? A to the 12th, we multiply, right? So here, when I've got this exponent, it actually becomes the coefficient in front, so I can multiply it. And then we can actually evaluate this. Because what is log base 2 of 4? 2, so this is really 6 times 2, which is 12. There are other ways you could do this. I could look at log base 2, and instead of 4 to the 6th, I could say, well, 4 is 2 squared to the 6th. So this is log base 2 of 2 to the 12th. So yep, that must be 12. Okay. You're not using the property there, but that's another way you can think about it. With logs, there's usually lots of ways, lots of different routes you can take to get to the final answer. So as long as you understand one of them, you're good. Questions on that one? Yeah.
How is it that you can move this 6 to the front?
So it essentially has to do with how your exponent rules work. Because of this actually means multiplying the exponents, and evaluating this is finding the exponent and then multiplying it. It's because the log base 2 of 4 is an exponent, right? Like, because you're thinking 2 to what power is this?
Yeah.
Yeah, so then this is also an exponent that you're multiplying by this other exponent to get that final. 12 is essentially an exponent, right?
Yeah.
Yeah, it's weird how it works. You're like, why does that turn into multiplication? But it's all back to those exponent rules. Does seeing it this way help at all?
Definitely.
Okay, good. So you can see, like, well, that's where the 12 comes. This is doing the same thing in a different route. Sometimes this gives you easier numbers to work with. It's one that your brain's like, logically, that doesn't make sense, but we'll get to it. All right, let's try another one. We're still expanding. You're probably tired of writing that word. Let's do natural log of x squared over x plus 4. So we've got a few rules going on in this one. So jot it down and then I'll talk you through some things. Okay, do you think this is equivalent to the original problem? No. Good. Okay, good. I'm seeing lots of, oh, we can't do that. Good. That would only be true if the entire fraction is squared. Okay? It is not, so we cannot do that. So we're going to go ahead and expand because of the division first, and then we'll deal with the exponent. So this is really natural log of x squared minus the natural log of x plus 4. How many of you really want to split up that x plus 4? Feels like you should, doesn't it? You can't, okay? When we're expanding, like if I were to write natural log of x plus natural log of 4, what would that mean I'm doing with the x and the 4? Multiplying, right? That's what natural log of 4x would look like expanded. You cannot expand x plus 4. You don't expand if it's originally addition or subtraction, only multiplication and division. Okay? So I can't like break that into any more natural logs. The only other thing I can do is, where does that exponent that's a 2, where should that go? Yep, in front of that first natural log. So 2 natural log of x minus natural log of x plus 4. That's it. That's all you can do. It feels unfinished, but it's not.
So you couldn't do like natural log of x plus minus natural log.
Oh, you could do that, yes. Sorry, I had to, my brain was slow there. That is what 2 natural log of x means. Yep. Because think about it, a plus in between means multiplied, like that actually means that. So yes, that's okay.
Would you prefer it that way, or are you okay with that?
I like it better with the 2 in front, but it's not wrong if you write them separate. All right. Let's try another one. Let's do, well, we're still expanding. Let's do natural log of x minus 4 squared over x times x plus 5 cubed. You guys try. Expand that for me. chat with each other. See if you guys agree. That sounded good.
Why would you want to
So it's just really understanding how the logs work. We're going to do solving with logs, and so understanding how those properties work is helpful to solving. Yeah. But yeah, it's just like, ooh, for a fun evening, we're going to expand logs. No, it's not like. Yeah, go ahead. All right, guys, let me write the answer. Let's see how we did. That's it, guys. 2 ln of x minus 4 minus ln of x minus 3 ln of x plus 5. Yeah? Okay, we didn't try to expand further, right? No breaking up the x plus 5s and the x minus 4s. Hey guys, again, these, like, don't have to show me a bunch of work. Like, it's completely fine to just be able to look at that and go, ah, here's my answer. That's great. If you show me work, that's fine too, okay? It's okay either way. You guys okay? Question or sure? You got it? Okay. All right. Okay, now we're gonna try.
Mr. Lee,
Yeah.
could I do, like a subtraction and then in parentheses having two things plus each
Yes,
other?
that's fine too.
If you were to condense that, would you go to like a double fraction?
No, because that's what that means. Right? Like if I factor a negative out, that's just what David is talking about. Here, let me go back.
How would you know that though if you just did this?
So anything with a negative is from your denominator. Yep. So another way to think about it, guys, is negative exponents. Let me write this another way. There's so many ways you can think about these. You agree with that? Is that the same, or even without expanding it? Let me do it this way. Go back. Even further. You see it, how that's the same as the original? So then if I expanded and did each individual exponent in front, so it doesn't actually mean like fraction over fraction. It's just, it came from the denominator. Okay. Okay. So we are going to go the other way, like starting with something like this. And you need to condense it. We'll do a couple of these. Let's do -3 natural log of x plus 2 natural log of x plus 1 minus 5 natural log of x minus 2 plus natural log of x plus 3. You are trying to write that as a single natural log. Okay? You are condensing that all the way down. So I'll give you guys a minute to try. Talk to each other. Did you get it down to a single natural log? How are we doing, guys? Still working?
The first thing I would do is I looked at which ones would be in the denominator. And then have and
Think we got it? Let me write the answer, and then let's see if you need me to go through any part of it. So that first one I know is x cubed, but in the denominator, it's plus 1 squared in the numerator, x minus 2 to the 5th in the denominator, and then x plus 3 in the numerator. Yes? No? Yes? Yes? Okay, okay. Let me stop for a minute. It's okay if you're like, no, I don't know what happened. That's okay. Just let me know. When I'm condensing, all I'm looking at is the coefficient. Is it positive or negative? So I see a negative coefficient. I immediately go, oh, that's from the denominator. Okay, so I know this x cubed must be in the denominator. Positive coefficient, numerator. Negative coefficient, denominator. Positive, numerator. Okay, and that's all you're doing. And the exponent has to go with it, and then you're just multiplying your numerators, multiplying your denominators. Okay. All right, let's try another one. -2 natural log of x plus 5. That's plus 5, sorry. -4 natural log of x plus natural log of x minus 3 minus 3 natural log of x minus 1. So same idea, I want you to condense that. Talk to each other.
When you're writing that answer, do you want us to put the brackets on old fraction or?
You can. If you're like, this is unclear what's happening, then use brackets. But okay, do we feel like we have it? Yeah. All right, let's see. Natural log. Looks like I only have one thing in my numerator this time, just x minus 3. And then I got a whole bunch of stuff in the denominator. I've got x plus 5 squared. I've got an x to the 4th. And I've got an x minus 1 cubed. Yay? Or sad? No. Are we yay? Okay. All right. Condensing. We get it? Yeah? Okay. All right. Okay, one more sort of weird thing to look at with our properties here. We are going to let natural log of 4 equal A, and the natural log of 5 equal B. We're going to rewrite the natural log of 20 in terms of A and B. Okay. The A and B do not come into play until the very end of the problem. Okay, do not be substituting those in at the beginning. They are an end of problem sort of thing. So I have natural log of 4 and natural log of 5 to work with. Do you have a way to make 20 out of 4 and 5? Multiply, right? Multiplying, dividing, and exponents, those are the only sort of options you have to make whatever number we're talking about. You can't add things. You can't say, oh, 4 plus 5. I know we're looking at 9 here, but you've got to use something where you can then use a log property with it. So natural log of 20, I'm going to rewrite as the natural log of 4 times 5. And then I can expand that. Okay, so that's natural log of 4 plus natural log of 5. Finally, now I can use the A and the B. So I can replace natural log of 4 with A plus natural log of 5 with B, and then that's it. Does that make sense? All right, let's try. I'm gonna have you guys try a couple. Let's do natural log of 100. Squeeze it in over here. The natural log of 0.25. Think about both of those. And there's several ways you can go about doing these.
I was like, no, I don't think so. But yeah, that would be so I like so much of my started.
Okay, yes. Okay, I'm like, wow, that's a lot of letters. Okay, and then what is that? one?
Yeah.
Yes, could you like simplify them? They're all right. Could you like? I like this one. That, I'm not sure if that's in there. Okay. Okay. What is that? Deal with those letters. Everything you can. Those things. Let's go through them. Lots of you got there. And again, there's multiple ways to get there on both of these. So I'll show you a couple different ways. So natural log of 100, you could think of natural log of 4 times 5 times 5. I'm trying to leave room to do this twice. So then expand. You could do that. A plus B, absolutely. A plus 2B. Yes. Okay, you could have seen it as an exponent thing and said, okay, that's 4 times 5 squared. So natural log of 4 plus 2 natural log of 5. With the exponents, guys, you want to make sure you deal with those becoming coefficients before you substitute in the A or the B. Because you can't substitute the B if you still have 5 squared. It's not B squared, it's 2B. Okay. So that one wasn't too bad. C is a little trickier. You have to think about what 0.25 is. I feel like the initial instinct is, oh, 25, I should be doing something with the 5 times 5. But you should not. That's not what 0.25 is. That is the natural log of 1/4. Okay? Again, multiple ways you could think of this. You could say, all right, that's natural log of 1 minus the natural log of 4. What is the natural log of 1?
0.
0. We talked about this last time. Remember, like log of 1 is also 0. E to what power is 1? So that's nothing. So this is just negative A. Or you could have been at this natural log of 1/4 and said, I'm going to write that as natural log of 4 to the negative 1. And then again, bring that coefficient out in front and you get negative A. So I don't care which way you get there as long as you get there without breaking any rules.
You just like went crazy and like did I did and then I did division. I did 5 times 5 over, or well 5 squared over 4 times 5 squared, and then got
So you like made it 25 over 100.
yeah.
That's fine. Yeah, I saw some people with lots of like B plus B minus B minus B. Like, yeah, you get there. It's fine. Yeah, you can take the long route. I don't care. You got there in the end. Okay, questions on any of that? All right. Would you guys like time to work on your math space? Yes? Okay, let's do that. So I'll give you the rest of class to work on math space. Remember, second attempts, guys. Do not leave all of these until right before the test. That's just not a good plan, okay? The test for you guys is October 15th, which sounds far away, we don't actually have that many classes before then. So next week, Monday's normal. Wednesday's kind of normal, except I'm going to be out. Friday is early release, parade, all of that stuff. So we only have 40 minutes in class. Following week, Monday you don't have school. Wednesday you would have class. You have the PSAT Friday. So we do your fake quiz review on Friday that's short. So you're probably going to start your fake quiz the class before. And then it's a whole week before your test. It's just terrible timing, but that's where it fell. Darn PSAT. I hate it that we just lose a day with the PSATs. You know, that it's just like black day on Tuesday, PSAT day, oh, we're back to a black day on Thursday. Like, that's just doesn't work in my brain for scheduling. But all right, guys, so go ahead and use your time. Let me know if you have questions. So Alex, you can do math base, right? Okay, nice. Oh, is it not showing yet? Oh, I think I made it available at 11. So 1 minute, guys. My goodness, this is like a really long minute. Okay, refresh. Is it there for you? No. Oh, I did make it. Let me edit. I made it 11:59. I don't know what I was thinking.
And for this second attempt for homework, is it still that 80% is prepared?
Nope, it's whatever you get is your grade on the second attempt. Okay. Okay. Do you see it now, guys?
Yes.
Yes. Okay. Good. Do you have a question on it?
So it's not so when you log a minus 9 squared, then
So isn't that 8 log of A's minus 2 log of A's?
yeah.
How many log of A's is that?
So I did that.
You get 6 log of A, right?
And I tried it wrong.
Because that's weird.
And she's
That seems odd to me. It's broken. Yeah, guys, let me look at number 2. I feel like something weird is happening with 2.
Yeah, so it's gonna say that yeah, it's really weird. I just
I'm checking. Mm-hmm. Okay, just a general log rule.
It says like set them equal to each other.
no, that's just saying that the exponent.
Oh, never mind.
Okay. I wonder if it wants you to write the steps. Let me try it. Let me walk you through 2, because it just looks weird. It looks different than how we did one. And you're thinking different rules than what are there. Let's see, it's log of a to the 8th over log of a squared, right? The rules we were doing were like log of a to the 8th over a squared. Do you see how this is different? So what they want you to bring the exponent in front. Like that's okay, right? If you actually simplify that fraction, what do you get? Okay, there you go.
That's so
Does that make sense? This was number 2 on your.
Oh, yeah.
I just got it completely wrong. I don't even have to.
Oh no.
If you were to have log a to the fourth, would it be 2 log a?
If you had log a to the fourth in the numerator or denominator.
In the denominator?
So you'd have 8 log of a over 4 log of a.
Yeah. Oh, it would just be 2.
2.
That's definitely, it would be bad. Wait.
Yeah, right.
Yes. Yeah.